Okay, you can set your boundary or like explain.
Yeah, sure. Actually, I'm just trying this to get out real quick, but there we go. But if you want to know, the basic boundary for today is applying what we know from rational numbers, components of that, and using that to help us understand operations of rational expressions. Specifically, simplifying, multiplying, and dividing. And it's also some prior knowledge for today.
Okay, yeah, you can start.
Well, I gotta, hold on.
Um,
I gotta get this guy up.
You?
You survived?
No.
No?
All of a sudden, something, I got hit with a cold.
Is it okay if I have my phone up here for time?
Okay.
Is that all right?
Yeah.
Is that okay?
Yeah.
Okay.
Okay. You have 15 minutes?
50, yes. So, yeah, what I handed out right now, you guys have a notes packet, so you guys are going to be using that in today's session to help record information that you learn, or personally record how you want to see the information in your style, in your way. So, hopefully it works.
I had this room last week, and
Did it do the same thing?
yeah, it took forever.
Oh, oh, there we go. Awesome. Ridiculous. I don't know what's going on. Oh, here we go. Okay, next. Hopefully it's not that slow to work.
This one took a while.
That's it, okay?
Yeah.
Yeah.
So,
Why
So, how about that riding?
How about that? I like to see, okay.
Good.
Can I get a full screen? Booyah. Okay.
We're in this.
We are in business. Okay. And am I good to start?
Yeah.
Okay. All right, ladies and gentlemen, boys and girls, it is time to start our next unit. And our unit for this next couple of weeks or a month is going to be focusing on rational expressions. In today's lesson, we're going to mainly understand how what we know from rational numbers and the components and the operations that go there correlate or compare to rational expressions. So we're going to use that prior knowledge that we know and apply it to rational numbers. And specifically, we are going to focus today, I'm going to move this guy over here so you can see. We're going to focus today on simplifying rational expressions that involve quadratics and polynomials, and then we're going to multiply and divide rational expressions. So those are the components and operations of rational numbers that we're going to apply to rational expressions today. But first, we have our brain starters today. These are your brain starters. Tess, you're going to be factoring x squared minus 2x minus 3. Jeremy, you're going to be doing that operation with rational numbers. Greg, you're going to be doing that operation. And then Dan, you're going to be focusing on those two short problems and how exponents play a role. When you guys are done, come up to the board, write your answer. I guess you can write it in this kind of space over here. And then we'll go over those real quick. When you guys are done, you have to come up to the board, write down your answers. We'll quickly go over those. You can write two at a time. Can you write?
No.
No, I don't think so. I have to look at it. Thank you, Greg. Oh, we gotta calibrate this guy.
Oh, yeah.
Oh, yeah, should have done that first.
That's a plus sign?
Is there any way I can calibrate that during?
No,
Yeah,
I
just
mean-
the two buttons.
Okay. Thank
No, thank you.
you. All right, now we can read your answer.
Yeah.
Okay. All right, Jeremy or Dan, if you guys want to come up next. Sorry that it's so slow, so low.
That's okay.
It's right here. Very good. Jeremy, you're so kind, you want to come up?
Fall over.
Okay, those seem to be all correct. Very good, guys. So, factoring x squared minus 2x minus 3 comes up to be x plus 1, x minus 3. Jeremy, your division of those two rational numbers is correct. We come up to be 2/3. Greg, your multiplication of those two, 1/2. And then Dan, the answers to those two are correct. We're going to use what we know here, what we just found out about these problems, and they're going to be incorporated later in the lesson. And I'll be calling on each one of you guys that had your specific problem, and you guys are going to be helping me and the entire class to explain a further concept. Okay? So everything that we just did in that brain starter can be used with rational expressions. Okay? So you guys are, already saw some rational numbers right there. I'm going to list a few. There was 1/2. There was 2/3. Another rational number I think we had, or that I can come up with, that there is 6/8. So a rational number can be seen as a fraction or a ratio of two numbers, where the denominator is not equal to 0, because we know that if we divide by 0, it does not exist. So based on what we know from that definition of rational numbers and what we have found out, I want you to take about a minute and work amongst your partner or by yourself and see if you can come up with the components or maybe a definition of what you feel a rational expression is. Go.
You got a smart one
Well, let's see, these are numbers.
Well, if we know that a rational
The
number
letter name.
is a ratio
Like letters.
of
Mhm.
integers, maybe
Like
this
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Like now I know my ABCs.
Okay, so like in your problem, your answer is like a squared.
and your
Would
coefficients.
that be a rational expression?
A squared is not a rational expression.
But you know, aren't you
Because
supposed
is
to-
that a fraction?
Yeah, I can see
It doesn't
that.
have to be, does it?
Yeah.
Fractions.
A rational number doesn't have to be a fraction.
Okay, so if we go to
Fraction or ratio.
Our first group right here, excuse me, yeah, if we go to our first group right here, Greg and Jeremy, I saw you guys were working together. Did you guys come up with any components or things that you feel rational expression entails?
Well, we said the rational number was a ratio of two integers, so maybe a rational expression would be like a ratio of expressions that only have integers as their coefficients.
Integers as,
As the coefficients in the, like an expression like 2x plus 1.
oh, so it involves a variable then.
coefficients.
Okay, so it involves a variable. Okay, so you said, let's see, you said a ratio of, you said a ratio of expressions, was that?
Yeah.
Okay. Expressions with coefficients, and then with coefficients and variables?
Yeah,
There we go.
with integer coefficients.
Integer coefficients, you know what, let me just pull that out there. Integer coefficients and variables. All right, very good, yeah. Anything that your group came up with in regards to rational expressions, maybe something you think it involves, or maybe just a definition, anything?
No,
Oh, you didn't come up with anything?
Well, we thought that, we kind of thought that it was, instead of numbers, we would use something like variables too, kind of like what they said.
Variable,
Something
okay.
like a over b or something like that.
Oh, okay. So the main thing that we're looking at here, so I'm gonna write that A over B that you said right there, because that was good. So the main thing that we're looking at here is variables. That's kind of the thing that both of your groups came up with, and that's basically what rational expressions are. They are a fraction or a ratio of variables, and we call these variables polynomials. So polynomials involve variables. So a ratio, or fraction, of two polynomials. And this was a great example that Dan just came up with as A over B, a ratio or fraction of two polynomials. Okay? So we're going to use that definition, we're going to use our definition of rational numbers, and we're going to go through each one of those operations. So, first we have our simplify. So, for simplifying 6 divided by 8, we know from our prior knowledge 6 divided by 8 can be reduced. And when we simplify rational integer, or when we simplify a rational number, what specifically are we looking for when we simplify a rational number?
Common multiples?
Common multiple. Common multiples. And when we're looking at common multiples, we're saying if we can factor out a common multiple. So, what specific common multiples are there in 6 and 8? Common multiple in 6 and 8. Yes, Dan?
24.
24. Why would you say 24? Oh, yeah, Tess.
I would say you divide by 2 to make it smaller and simplified.
Okay, so divide by 2, if you do each number by 2?
Yeah, that's what I meant, I'm sorry.
Oh, okay. So if you divide each number by 2, you would get
3 over 4.
3 over 4.
Yeah.
That's correct. Yeah, Dan, for common multiples, we're looking to see what common factor that each number has. Does that make sense?
Yeah.
Okay. So, in this case, we can rewrite 6 over 8 as 2 times 3 over 2 times 4. And we see that 2 is our common multiple in each expression. And so what we're able to do is cancel out those 2's and get the answer that Tess just said, 3 over 4. So when we're simplifying, we are mainly just canceling out or dividing the common factors, okay? So based on what we know from simplifying rational numbers, take a minute, again, talk amongst your partners, and try to work on these 2 problems. Take about a minute or so and see what you guys can come up with, okay?
Or like a set number.
We're supposed to simplify these, right?
Yes, so try to look at the common multiples like you found in the rational numbers and see what you can do with these. Chester, you want to work by yourself. I mean, if you don't, if he doesn't want to work with you, then you work by yourself.
Okay.
Smart, I'm not the smart one. Greg's the smart one.
Yes, very
Maybe if he's nice, maybe if he's nice, he can help you out.
Yeah.
All right, so let's look at our first, all right, so let's look at our first problem, x plus 4 over x plus 2. What things did we come up with as a possible solution?
Well, we couldn't find a common factor, so we felt it was simplified.
Okay. That's correct. You couldn't find a common factor between x plus 4 and x plus 2. There's nothing that you can take out of either number or either expression that could be taken out of the problem. Okay? Another way to think of it is when we simplified for rational numbers, we were undoing multiplication. Okay? So division that we see right there, simplifying, undoes multiplication. We're not multiplying two numbers right here. We're just simply adding them, x plus 4 and x plus 2. Okay? Again, you can think of it as one term, x plus 4, one term is x plus 2. Okay, very good. So this is simplified. Very good. 3x plus 12 over x squared minus 6. Did we see if we can factor out any common multiples with that? Yes. Tasha, shaking your head. Which?
Yeah, so for the top, I divided by 3. So I like pulled out the 3, so it'd be like.
Factored out the 3.
I
Good,
factored
yeah.
out the 3,
Okay.
there we go. So it's like 3 times the quantity of x plus 4.
X plus 4. Okay.
And then for the denominator, I like factored, so it'd be like x minus, like the quantity x minus 4 times the quantity of x plus 4.
Okay, yeah, that's right. It's the difference of perfect squares.
There you
There
go.
you go. Difference of perfect squares. So x plus 4 and x minus 4. Now, what may seem a little interesting here is that we have two numbers that are getting multiplied on the top, two numbers that are getting multiplied on the bottom. Since we are multiplying, we can undo that with division. So is there any common terms that we see on the numerator and denominator? Any common terms? Yes, Dan, what, you're shaking your head, what's up?
X plus 4.
X plus 4. We have two x plus 4s, one in the numerator, so we can cancel those out. One in the numerator, one in the denominator. So we are left with 3 over x minus 4. Okay? So not only can we cancel numbers, but we can also cancel expressions, like x plus 4. Okay? So when we are doing simplifying, our main, oops, I gotta put this pen down, thank you. Our main steps that we're doing is we're factoring the numerator and denominator and then reducing, simplifying, and canceling out. That's our main step that we are trying to utilize to simplify the problem. And in this case, we weren't able to do it because we couldn't factor anything out of the numerator, we couldn't factor anything out of the denominator. Yes?
If we put negative 4 in x with this fraction,
Yeah, this one here?
no, the first initial one, the first one, the original one.
Right here.
3x, yeah.
Yeah.
And I can get 0 over 0, but when I put x minus negative 4 in simplified fraction,